Good afternoon, parents and children. We are going to be investigating geometric patterns. We're going to start with number patterns just to get the children's brains thinking in terms of numbers and different properties and operations. And then we're going to move towards the geometric patterns. So the questions I have here are questions that they get in their brain quest from Green Shoots. I use them because I want the children to get used to the kind of questions they get when they are doing their brain quests, so that they are familiar with the way you respond to questions like this. Okay, so write down the next number in the pattern. So if we look at what we have here, we have 6, 12, 18, and 24. Now, normally children will think of, okay, I must add a number every time, and then I can get to the next answer. Okay, so that's not incorrect way of thinking, but I'm going to guide you as we use that. Right, so if you look at 6 and it becomes 12, then you can see the numbers are increasing, they're becoming bigger. So they're not becoming smaller or less. So that means you are either adding or you are multiplying. Okay, so the first thing that you normally test is whether you are adding the same number. So from 6 to 12 you add 6, and from 12 to 18 you will also add 6, and then from 18 to 24 you will also add 6. So here we are using the same number. Okay, so it's plus 6 plus 6 plus 6. So the difference between these numbers are the same. Okay, so that means we are using on what we call the constant difference. I want them to remember these words. The constant difference means that constant means that it will not change. It will stay the same. Okay, so the constant difference in this pattern is 6. So let me just write that also. The constant difference is 6. So because you add 6 every time, so then it's easy to get to the next number. So what is 24 plus 6? That is 30. Okay, right, so let's go to the next question. So now we always start with a constant difference. Is do we have the same number that we add or subtract every time? Okay, so if you look at these numbers, you have 201, 301, 401, 501. So the only thing that's changing here are the hundreds. So what are we adding every time? Because the numbers are becoming bigger, we are adding 100 every time. So now you will know what will the next number be. It will be 601. So remember the words, the constant difference in this case is 100. Okay, right, let's go to the next one. This one is an interesting question because you will see you're not going to use a constant difference. There isn't a number that the same number that you add every time. But remember, you must ask yourself, are you going to be adding or are you going to be multiplying? If I choose multiply, then I ask myself, what times 3 equals 9? And that would be 3 times 3. So then test it. Okay, will that work for the next number? So then say, okay, what's 9 times 3? That is 27, and you can see that will be the third. That's your third number. And then okay, so and 27 times 3 equals 81. So what operation am I using here? I am multiplying with 3 every time. So then go calculate. What is 81 times 3? And that is 3, and that is 24. So this equals 243. Right, so you see the next section, we are going to look at what are geometric figures. That means that is the collective name for 2D shapes and 3D objects. So squares, rectangles, circles, ovals, octagons, pentagons, spheres, cubes, prisms, pyramids, cones, cylinders, all of them together they are called geometric shapes. So now we're going to look at patterns that doesn't involve numbers like this, but involves shapes which creates the pattern. So that's why we call it geometric patterns. So let's look at an example. So this one, these two are also from green shoots. So it says, use the diagram to determine the number of blocks in the next shape. Okay, so what I want you to remember with a pattern, you have terms. Terms is the name for each stage. So this is the first term, so I can say this is term 1, this is term 2, this is term 3, and this is term 4. This is just a way of naming the different stages of the pattern. And then here we're going to count how many squares or blocks do you see in each one of them. So there's 1, 2. Here we have 1, 2, 3, 4. Here we have 1, 2, 3, 4, 5, 6. Then we have 1, 2, 3, 4, 5, 6, 7, 8. So you can realize what the pattern is. You're going to add 2 every time. So 2 in this case is our constant difference. So what will be the next number or the next number of blocks in this pattern? You add 2 to 8 and then you will know it would be 10. Right, so let's move to the next one, interesting one. I want you to pay attention when I'm explaining this one. So remember, this is term 1 of the pattern, this is term 2, and this is term 3. Okay, how many squares do you see? This one has 4. This one has 1, 2, 3, 4, 5, 6, 7, 8, 9. This one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now you can see there's quite a big difference between these numbers. If you say 4 plus what equals 9, you will say 4 plus 5. But you can't add 5 to 9 to get to 16. You're going to think of a different way. So what I would like you to explain to you is that these numbers 4 and 9 and 16, we call them squared numbers, and there's a reason why. Squared numbers. Squared numbers mean that a number multiplies with itself, and that gives you the answer. So a number multiplies with itself, and then you get the answer, which we call the squared number. Okay, so what number multiplies with itself that equals 4? That would be 2. 2 times 2 equals 4. And what number multiplies with itself that equals 9? And that would be 3. 3 times 3. And what number multiplies with itself equals 16? And that would be 4. Can you see a pattern now? Yes, 2, 3, 4, and then it would be 5. 5 times 5. And what does that equal? That equals 25. So that is the number of blocks that you will get in the next diagram in the sequence. Right, then we get to describing patterns in words. It says, describe the following sequence in words. Select the correct answer. So here we have 2, 4, 8, 16, 32. You can see that they are increasing. If you think of adding a number, if you say, for example, 2 plus 2 equals 4, plus 2 will be 6 and not 8, so that will not work. So think of multiplication also. 2 times 2 equals 4. 4 times 2 equals 8. 8 times 2 equals 16. So what we do here is we multiply with 2 every time. So then select the correct answer. Double the previous number, add 2, subtract 4, multiply by 3. It would be double the previous number, because double means to multiply by 2, or you add the same number. 2 plus 2 is 4, 4 plus 4 is 8, 8 plus 8 is 16, and so on. Right, let's go on to the next example. Describe the following pattern. Choose the correct answer. 18, 16, 21, 19, 24, 22, 27. So it's becoming less and becoming more. So you are subtracting and you are adding. So in this case, we minus 2, then we add 5. Then we minus 2 again, and then we add 5 again. And then you minus 2, and then you add 5. So you can use more than one operation in a pattern. So which one is it? Is it subtract 2 and then add 5? Is it subtract 5? Is it subtract 5 and then add 2? Or is it subtract 2 only? And we can see it's subtract 2 and then add 5. So it's the first answer is the correct one. Okay. Right, now we move to your DB ebook. And then on this page, you will see describe the pattern using the statements below. So you're going to choose between these two sentences and you will write it here underneath each pattern. It says the shape keeps its form but gets larger or smaller in each stage. So if we look at this one as an example, the shape doesn't change. The triangle doesn't become a square or a rectangle or whatever. It stays a triangle, and you can see the sides are the same lengths. Okay. And then another one, it says a shape or part of the shape. Oh, sorry. So there's the triangle, the shape stays the same, but it becomes bigger or smaller. And then the second one says a shape or part of a shape is added at each stage. So here we see 3 circles, and then we have 5, and then we have 7. So the circles are added. So it will definitely be this one. A shape or part of the shape is added at each stage. So now you just go and you fill in the sentence that fits the pattern. So I will take the first one for A. So I'll say the shape keeps its form but gets larger or smaller in each stage. Okay, and then the next one, a shape or part of a shape is added at each stage. So you see there's an example here, patterns in which a shape or part of the shape is added at each stage. So you will see the square with a triangle at the top, or the house. There's one house added in each stage. Right, let's go to the last example. And this is on the next page in your DB ebook. It says, describe the pattern using the statements below. So again, you will choose between two sentences and you will write them under the appropriate pattern. So you will see here 1, 4, 9. So the difference between 1 and 4 is 3, and the difference between 4 and 9 is 5. So this one there's no constant difference here, and it says the pattern does not have the same difference between the terms. So then you will choose the pattern with the same difference between the terms, or you will choose patterns do not have the same difference between the terms. So let's look at how many triangles we see here. There's 1, we have 4 here, 1, 2, 3, 4, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. We're only looking at the small triangles. We're not looking at any other triangles you will find in this in each stage. Okay, so what do we see? 1, 4, and 9. And the difference between 1 and 4 is 3, and 4 and 9 is 5. So it does not have the same difference between the terms. So then it will be definitely the second sentence. So I will say patterns do not have the same difference between terms. Right, and then we look at the next one. Here we have a triangle again. 1, 2, 3, 4. And 1, 2, 3, 4, 5, 6, 7, 8, 9. It's the same as this one. So again, you will say patterns do not have the same difference between terms. Okay, homework, page 98 to 99, and thank you for listening.